So this is example 5 for notes 1.5, section 1.5. Now we are going to create a function to illustrate dropping an object. Now of course this is going to be a quadratic function because that's what we're working with, okay? So let's kind of read the question and then kind of go over how we create the function. So for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does the container take to hit the ground? Okay, so here we know that we have to figure out how long, so that's kind of like seconds, minutes, basically the time, okay? And then it tells us also the initial height, which they drop the egg from a height of 50 feet. Now this is a equation that we're going to use a lot, okay? So h in this case just represents height, so and then equals negative 16t squared. T represents time, in this situation seconds, and then we have plus, this is what we call h naught. This is the object's initial height. Now we need to create the equation. Now we always start with h because we always want height, so we do height equals. Now, if some of you are in physics or are going to be in physics, this negative 16t squared, you will always have this. This is just a physics law. That means that we're going to have a quadratic function. And it really talks about more about projectiles, and we'll talk more about that a little bit later. So this negative 16t squared, you will always have this when you create your function. So that never changes. So there are two things that you will always have when you create your function, the h and equals, and then negative 16t squared. Now the thing that will change is the object's initial height. So this is where you draw it. Sorry, this is where you will drop the object. Okay. Now they see that they are dropping the egg at a height of 50 feet. This is what we would call our initial height. Okay. So where the h naught is, that's where we're going to put the 50. So we do plus 50. Now here they're asking, how long does the container take to hit the ground? Now the ground, if we kind of think about it, that's at a height of 0. Anything above the ground is a positive height. Anything below the ground is a negative. So what we're going to do is we're going to take the ground and put 0 in for h. So we're going to plug 0 in for h because the ground is at a height of 0. So we have negative 16t squared and then plus 50. Now this is what we've done with the other examples. We are going to solve for a variable, in this case t. Okay, so to solve we are going to first subtract 50 because we are trying to isolate our variable. So remember, just like with multi-step equations, we always add or subtract first. So in this instance, we're going to subtract. So we do minus 50 and then negative 16t squared. Okay, this is a 50 right here. There we go. Okay, our next step is, once again, we got to get t squared all by itself. So to do so, we're going to get rid of this negative 16 by dividing both sides by negative 16. Now here you are going to get a decimal, which that's okay to get. Okay, so we have equals t squared. So in your calculator, just make sure you do negative 50 divided by negative 16. Let me redraw that so you guys can see that a little bit better. Okay, so we said we have negative 50 over negative 16. Okay. So this, we should get about 3 point. So when you divide, you should get about 3.125. Okay. Now we need to get rid of this square. So remember, to undo a square, we have to take the square root. So here then we get t. Now, and the other problems, we always left it in simplest radical form. But in this case, because this is a word problem, you can take the square root of 3.125 and get a decimal. It is okay in this instance because we are doing a real world problem. So you go ahead and plug this into your calculator. If you do not know how to do that, let me show you really quick. There we go. Now make sure all you have to do is do second square root and then we just put 3.125 and then press enter. And then here we're going to round to the hundreds. So we're going to put 1.7 and then we got to round up to 7. So our answer here is 1.77. Now let's go back to see what we had to write as our label. We're in seconds. So at 1.77 and then we're going to put seconds. Okay, let me rewrite that so I have room here. So our final answer here is that it took 1.77 seconds for the container to hit the ground. And then this would be your final answer. Remember, the homework is on Google Classroom, or you can look at your pink assignment sheet. If you have any further questions on this or any of the examples we did in class, make sure you email me or come in tomorrow morning.